We've already seen that classes have methods as well as properties and events. And methods are often referred to as functions. Functions are simply blocks of code that can be executed with a single calling statement. This lesson is going to focus on custom functions, and there are lots of advantages to working with functions in our code. As our programs get more and more complicated, our event handlers that are responding to the event listeners can get longer and longer and harder to read and harder to debug. By breaking them up into smaller chunks using functions, it makes our code much easier to read and much easier to debug. Also, as we get into more and more complicated programs, it's likely that you'll be working with other programmers or doing this in a team environment. And so different programmers or different teams can take on different aspects of a program and write those away from the other programmers and then bring those all together, because they will be self-standing units that are just then linked together through our calling statements. So it allows us to divide and conquer a much larger project. And since we can call our functions with a single statement, there may be times we want to use the functionality of our function multiple times, maybe calling it from different event handlers. And this will allow us to reduce our code. Functions are generally self-contained, which means I can write it one time in one project and then just simply copy and paste it into other projects, and it's a huge time savings. And then, as we've already seen, methods are a big part of classes and object-oriented programming. So learning to write just custom functions at this point will help you when we get into creating our own classes. We've actually been using functions. Here's a snippet of code in which I have xyz as an integer variable, and then I can use the math.random function or method to generate a number between 0 and 1, multiply that by 6, add 1 to it, and then take that result and call it in the math.floor function, which will truncate the decimal. We've used this in the past when we wanted to roll a die. This will give us a number between 1 and 6. We've also used the trace method or trace function in the past, in which we simply display some text in the output window. Each of those are simply statements that call a much larger block of code that's doing some processing. Those functions were written for us. They are built in, or sometimes referred to as global functions. We've also used functions for our event handlers. So I can add an event listener to a button that calls a function called clearMe. And then we've defined that function of clearMe, and we have a parameter in parentheses which refers to the calling event. And we refer to that event as the variable e, or the event is placed in variable e. And then we saw that it returns nothing. We've used :void throughout the course so far. And then the stuff we want to have happen inside the curly brackets. So this is the code of our function. Well, we can rewrite this using a custom function. So I still have my event listener that's calling my event handler of clearMe, and then inside that I have a calling statement to a user-defined or custom function called clearTheInput. And I've written that function using the function name, just like we created our event handlers. The name of my function, clearTheInput. There's nothing inside parentheses because there's nothing being sent to it, and we'll look at that in the next video as far as passing values. And it's not going to return anything. And then the code that I want to have happen. So in essence, it's sort of like taking a detour. I click the clear button, it calls clearMe. clearMe calls clearTheInput, which does all this, and then returns the control back to the statement after clearTheInput. And there might be other code that I would have execute there. So this is how we can modularize our code and break it up into smaller chunks. My event listener, event handler function might call several different custom functions. Well, let's take a look at this in a project. So we've done this dice rolling project in the past, and I'm just going to go ahead and execute this. So I'm rolling my dice, and I'm generating two numbers randomly. The problem is it's possible that the next time I click roll them, I could get another 5 and a 2, and it looks like nothing happened. So wouldn't it be nice if we could change the color of the background or the stage every time I click roll them? And you know, that's might be a useful routine that I could use in other projects. So as we look at our code at this point, I have an event listener that's calling my event handler function for Roll'em. Well, let's modify this. So I have modified my code by creating another function called change stage color. I could have named it anything I wanted as long as I follow the naming conventions. No spaces, one word. I like to use camel casing with the first letter capitalized. It's not being sent anything, so there's nothing in the parentheses here. The return type is void. So a void function does something. It doesn't return anything, it simply does something. And in this case, I'm going to cycle through colors of the stage. And I'm using a switch statement to look at whatever the color of the stage is, and if it's white, I'm going to change it to yellow. If it's yellow, I'm going to change it to magenta. If it's magenta, I'm going to change it to cyan, and if it's cyan, I'm going to change it back to white. So we'll cycle through those 4 colors. That's all this function does. So I call it, though, from my function, I have the statement change stage color. So we call a function by specifying the function name with parentheses. So one way we can tell this is a method or a function in the calling statement. It's going to have parentheses. And if I was going to pass it something, I'd have things inside the parentheses. And we'll look at that in the next lesson. Let me just go ahead and run this. And so now, whenever I click Roll'em, it's rolling the dice, randomly generating my pair of dice, and it's also changing the background of the stage. And there may be other projects that I want to use that in. All I have to do is come in, copy this code, and paste it into that other project, and then whenever I want to use it in another project, I simply call it with this statement. Well, here's another example. Playing Tic-Tac-Toe. This is again a much larger project, and if we look at our code, let me see, there's about 100 lines of code here. And I have my variables that are set to begin with, and then I'm calling a method called clearMatch and clearBoard. ClearMatch simply sets the scores between the 2 players playing tic-tac-toe to zeros, and clearBoard sets all of the X's and O's to nothing on my tic-tac-toe screen. But both of those are routines that I may want to call from other areas, and that's why I modularized this. So when I click the Clear Match button, or the New Match button, it's going to call a routine called New Match. There's my event listener, or event handler, and it calls this Clear Match function. Same with my new game, calls the Clear Board function. And then here are those 2 functions, Clear Board and Clear Match. Now since I'm using these more than once, I've just saved myself, in this case, about 8 lines of code, and same with here. I also have another function here called check for win. Now I didn't put the void at the end of this. If you don't put void, it assumes void. It's probably a good habit to get into to put that there. And this function is going to be called from an external movie clip. But it's here on my root timeline because I'm going to have 9 movie clips that are going to call it. I only had to write this code once rather than 9 times. And you notice that it's a fairly long function. Huge savings both in time and readability. And then also a function here called update scoreboard, and that's being called from inside this function, not once, not twice, but 9 times. So this modular approach is going to help me really reduce the amount of code that has to be written and make this much more readable. And then my tic-tac-toe game is actually 9 movie clips. Each one of these is a object called MCXO, or in this case the instance name is square 1, square 2, square 3, and so forth. And there is code in each of these. I'm going to burrow down into it. So each of these have the same action here. When I click on the square, it's going to set that square to either X or O But then once I do that, I'm also calling the check for win function that we had in our root timeline. And I do that by calling the movie clip root.checkForWin. Just as we navigated the timeline back in our second week of the course using movie clip root. So I could navigate the root timeline from this movie clip. In this case, I'm calling a root function from this movie clip. And that's the extent of my code. There was about 140 lines of code there total between all the objects, much of it being used multiple times. Let me just test. And so we can have two players. Let's say we've got Jim and Bob. I'm going to click New Game. Jim gets to go first. I'm going to take the middle square. O plays. Jim plays. O plays. In this case, we had a push. I click New Game, it clears the board. Now Bob's going to go first. And Bob's in trouble. Or Jim's in trouble. Bob wins. And the score is updated, showing a win for Bob, and we have one push. If I click New Match, those are all set to 0, and then I can clear the game again.